The question reads, graph. The function given is an already factored polynomial. So we're just going to follow the polynomial procedure given in the lecture notes. We need to find the end behavior of this. So I need to find what my highest power is without necessarily having to FOIL all of this out. I have 3 x's here because my expression is quantity cubed, so that's 3 x's. There's 4 x's and 5 x's. So my highest power is 5. So my degree is 5. The leading coefficient is 1 because that's what's in front of the first parenthesis. There's nothing there, so it's a 1. So my graph will fall to the left and rise to the right. Second thing I need to find is my x-intercepts and their multiplicities. The multiplicity will tell me what's happening at that particular point. Since my expression is already factored, I just have to set each factor equal to 0. So x plus 3 is equal to 0. X plus 1 is equal to 0. X plus 4 is equal to 0. So we can say x is a negative 3, x is a negative 1, x is a negative 4. I have a multiplicity of 3 on negative 1 because my power was 3 on the parentheses. So negative 4, 0, negative 3, 0, negative 1, 0 are my y-intercepts with the multiplicity of 3 on negative 1. I need to find my y-intercept. To find the y-intercept, I will plug 0 in for all of my x's. So f of 0 is equal to 0 plus 3 times 0 plus 1 quantity cubed times 0 plus 4. So we have 3 times 1 times 4, which gives us 12. So the y-intercept is 0, 12. Looking at my equation, my turning points, the max number of turning points, is to take my degree or my highest power, in this case 5, minus 1 is equal to 4. So I have a maximum of 4 turning points. No more than 4. I'm going to plot the information I currently have to see if I need to find any more information. So we know my graph will fall to the left. We'll know it rises to the right. We know that we have an x-intercept at negative 4. We have x-intercept at negative 3. And we also have an x-intercept at negative 1. We also know I have a y-intercept at 0, 12. And it shouldn't turn more than 4 times. So there's a turning point somewhere between -4 and -3. Okay. So I'm going to pick the point for additional points just to get an idea of where it's turning. F of -3.5. And I'm going to plug that into the original question. So it's a -3.5 plus 3 times a -3.5 plus 1 quantity cubed times a -3.5 plus 4. If I multiply all that out, I get approximately 4. About 3.9-ish to be exact. Approximately 4. So this tells me I have a point at -3.5, 4. So right about there is going to be a turning point. I also know I have a turning point between -3 and -1. So I'm going to test f of -2 because it's between -3 and -1. So we have -2 plus 3 times -2 plus 1 quantity cubed times -2 plus 4. That's going to give me exactly -2. So I have the point -2, -2. I have all the information I need to get the general shape of this graph. So we're going to go up from -4 to the turning point, turn at that turning point, come down through -3, go down to -2, 2, turn, go up through -1, and head all the way up to a +12, and go on from there. And that's what my graph looks like, something like that.